Hello, so in this short review video, we're going to review triangle congruency postulates. Now this is not meant as like a first time lesson, it's a review for my students, so if you're like, it's coming at me too fast, it's because I'm really not going into much detail here. But these are the triangle postulates that we explored and figured out that worked. We have side, 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 side included angle side, angle included angle side, and so forth and so on, angle, angle side. And then this one right here, we actually didn't use a ton, but it's important to us. HL is the hypotenuse and leg of a right triangle. So let's look at these really quick and remind ourselves how they work and why we care about them. And so in all of these examples, what we're trying to do is see if there's a way that we can show the triangle is congruent. So is there a way that we can say that triangle ABC is congruent to triangle DEF? And if this statement is true, this means that angle A would be congruent to angle D, angle B would be congruent to angle F, angle C would be congruent to angle F, and so on and so forth with the side lengths. AB would have to be congruent to DE, and BC would have to be congruent to EF, and so on. So when we set about doing that, we notice that, hey, we have three sides in common. So we can show this statement true using the side, side, side postulate. And if I was going to list that out, I could say that AB is congruent to ED, or DE, it doesn't really matter. I should probably notate it the same way though. DE, because remember they're corresponding. So this one is equal to this one, and those three hash marks indicate that. So that's information we were given. And so then I can say that BC is congruent to EF. And then finally CA is congruent to FD. And so with that, we can make the statement, the final statement, that this is true, that triangle ABC is congruent to triangle DEF because all three sides are congruent. So the angles, therefore, must be congruent. And so with using those corresponding parts, we can clearly see two congruent triangles. This one's interesting. They give us a little bit of different information. They tell us in this case, it's given that C is the midpoint of AD and BE. So based off the definition of a midpoint, if C here is the midpoint of AD, then that means that AC must be equivalent to CD. And if it's the midpoint of BE, then this BC must be equivalent to CE. So you can see clearly now that there's two corresponding sides in common between these triangles. But we need something more than that. So in this particular case, I have to also notice that these angles would have to be congruent because they're vertical angles. These are vertical angles formed by two intersecting lines forming two congruent angles. And so now I can make triangle ABC congruent to DEC using the angle, or excuse me, let me rewrite that. Using the side included angle side. Now we say side included angle side simply because the angles that we're saying are congruent are sandwiched between the sides that we've noticed are congruent. And so we can say that triangle ABC is congruent to triangle DEC based off of the SAS postulate. So in this particular example, we're given that angle ABD, so this angle right here, is congruent to angle CBD, or this angle here. And similarly, we're given that these angles, ADB, is congruent to CDB. So I can write that as well. So angle DB is congruent to CDB. But that's not quite enough information to prove that, oh, by the way, what are we trying to do? That's probably important. We're really trying to show that triangle ABD is congruent to triangle CBD. And so we're looking for postulates that can help us prove that and demonstrate that. And so, as you can probably tell, this side is congruent to both triangle ABD, this one right here, and CBD, because it's shared by both of them. And because of that, we can use the angle included side angle postulate. This angle this side sandwiched between these two angles makes it angle included side angle. All right, we've got just two more. Okay, this is interesting because you have to look at what we're given in this case. In this case, and I haven't really notated anything, I haven't really named anything yet, but we're just going to try and show this triangle up top here is congruent to this triangle down below here. And without naming anything, we can just talk through this. We see that these are vertical angles, so they must be congruent. So we've got a pair of vertical angles here. And that now allows us to do angle, angle, side. So as you can see, we've got an angle, and a side that corresponds to an angle, and a side of this other triangle. So maybe it would be a good idea to name these. So this is, let's call this A, we can call this B and C. We can call this D and E if we'd like. And so what we can do is we can say that triangle ABC, excuse me, so this one here on the bottom, is congruent to triangle DBE, and I forgot, of course, the triangle symbol. Let me fit that in there. And we can say that because we can use the angle, angle, side postulate, because we've got this angle, and this side that corresponds to this angle, and this side. So angle A corresponds to angle D. These two angles correspond, and then these sides correspond. And so now, hey, we've got two congruent triangles. And last but certainly not least is this figure here. And we'll name this A, maybe B, C, and let's go ahead and name this point D. And so the goal here would be to prove that triangle ABD is congruent to triangle CBD. And notice I'm trying to keep track of my corresponding parts when I name these, because I know that A is going to correspond to C, and I know B is, the same point, point for both triangles, and similarly D would come last for both triangles. So I'm trying to keep the points in the same order so that the corresponding parts match up. That's the goal. Now, to be able to demonstrate that these triangles are congruent, we can simply use the HL postulate. So the HL postulate states that if you have two right triangles and they share a hypotenuse and they share one leg, then you're guaranteed that those particular triangles are congruent. Now, if these were not right triangles, and this was just a common angle here and a common angle here, that would be the angle side side postulate, which we know does not work because there's potential that the triangles wouldn't be congruent, so it's not a good enough proof. But in this particular case, they also happen to share a side. They also happen to share this side here. So we could, even if these weren't right angles, just because we know this and these are the same and that they shared a side, then we could use side, side, side. But I just wanted to point out that you can't use angle, side, side because that postulate doesn't necessarily prove the triangle's congruent. So the only time that you can really use an angle and two sides is when they're right triangles. And we actually call that the HL postulate. Again, I want to emphasize this was a very quick review video. And so if you've never explore these postulates for yourself to see why they work, this is not the right video to watch because you really need to dig down and do some explorations to figure out, why does side, side, side result in congruent triangles? Why does angle, side, angle result in congruent triangles? This was just a brief review to something we have already studied in depth. All right, thanks, guys.